Okay, and welcome to today's short introduction to forces at an angle and trig. I know we've done forces at an angle previously in terms of force diagrams, but now we have to look at what does it mean that those forces are at angles to each other and how does that affect our understanding and our ability to use them. So I'm going to start by putting my x and y axis on this squirrel. This is the same squirrel that was on top of a roof in activity 3.2, I believe it was. So I'm going to start with my x-axis, which I'm going to make parallel to the roof, and then my y-axis, which I will make perpendicular to my roof, because then it sets me up with a coordinate system and I can rotate my coordinate system just like I'm going to turn my head to look at it so it's straight on instead. We also know from what we have done previously that this squirrel is sitting there on the side of the roof. He's not sliding anywhere, so he has balanced forces on him. So he has the force of gravity going down, going straight down, remember, not at a slant, but going directly straight down to the ground. We also know that there's a normal force on him, the force between the squirrel and the surface of the roof is what's going to the roof is going to exert back up on the squirrel, so he stays there. And that force is directed perpendicular to the surface, so that force is right here, right on the y-axis. So if we look at just those two forces, and we forget about the squirrel, we forget about the roof, and I rotate the axis so that the axis is a horizontal vertical axis, just like we're used to seeing, what we end up with is, let me change color here. We end up with a normal force, which is again on the y-axis, but now our gravitational force is no longer pointing straight down, it's now pointing at an angle. Because I've rotated the axes around, so I now have this angle here has been rotated, the whole set of axes has been rotated down by that amount. So if let's say that we say that this slope of the roof was at 25 degrees, then this angle here is 25 degrees. Now, obviously, this is a little bit out of proportion. This is not a 25 degree angle. It's much closer to about a 45. But let's pretend for the moment that it is. So now the question becomes, if we have the normal force going up and the gravitational force at an angle, how can they interact with each other? The thing that's important here is to realize that the forces in the y direction interact with other forces in the y direction. Forces in the x direction only interact with forces in the x direction. So forces interact with other forces that are parallel to them. So does that mean that the force of gravity here, F of g here, doesn't interact at all with F of n? No, because there's a part of F of g that's in the y direction. And if we separate that out here, we can see that, well, there's force of gravity, some of it is going this way, which I'm going to call Fgx, and some of this is also coming straight down, and I will call this Fgy. So for the squirrel, let's go back to the squirrel for a minute here. For the squirrel to be sitting there on the roof, gravity's pulling him down, the normal force is going up, but we forgot a force here at the beginning that will help balance all this out. There has to be some sort of a frictional force occurring that's keeping him from sliding off of the roof. And we had neglected that to begin with. So if we have a frictional force there, we have to add our frictional force over here as well. So our frictional force here is going to be facing this way, still in the x direction. So now as we take a look at these forces, we had started with 3 forces: normal force, frictional force, and gravitational force. But now we're really to having 4 forces. We have 2 in the y direction and 2 in the x direction. So in this picture, when we're talking about what's going to interact with what, we can talk about the fact that the normal force is parallel to the force of gravity in the y direction. And the force of gravity in the x direction is parallel to the force of friction. That means that these are our 2 force pairs that are going to work with each other. So let's talk about how we can figure out what Fgx is and what Fgy is. We basically have Fgy here, Fgx here, and then the force of gravity overall there. And we said that this angle was 25 degrees. If you know any trigonometry right now, then you already know this information and you don't have to worry about it. But if you don't know it, this is a good introduction to it. When we are talking about angles and triangles and sides, you may know Pythagorean theorem. Pythagorean theorem says that a squared plus b squared is equal to c squared. Well, in this particular case, what that means then is that the force of gravity in the x direction squared plus the force of gravity in the y direction squared is equal to the force of gravity squared. This is important to realize and this is important to remember, but it still doesn't tell us what Fgx and Fgy are. We have to take the next step with that and we have to use trigonometry. Trigonometry is the relationship between angles and sides of a triangle. It's often taught in terms of a circle and how many degrees you have going around in a circle. We're just going to touch the basics of it right now. Okay, so I am going to simplify this triangle even a little bit more and say, all right, well, what if I just go back to a regular right triangle? I'm going to say that this is side A, this is side B, this is side C. I could also say that this is the hypotenuse. This is, if I'm looking at this angle, because this is the angle that I know, 25 degrees, side B is also the adjacent. And side A here is the opposite. In order to be able to make a relationship between these, we need to introduce a new function. Think of this similar to if you're going to raise something to a power, like you're going to say x squared. If I want to square something, then I write it as x squared. The opposite of x squaring is square rooting, right? So if I've squared something and I want to do the opposite, I square root it. So these here are what we call inverse functions. They do the opposite of each other. When we're talking about functions in trigonometry, we have similar sort of situations. The first one is called the sine function. And you sine an angle. So you take the sine of an angle, just like you take the square root of a number. And it looks like this. Sine theta, and by definition, sine theta, theta being the angle, is the opposite over the hypotenuse. So again, 25 degrees is our theta. And so sine theta is opposite over hypotenuse. Keep this in mind. We also have cosine theta. Cosine is abbreviated COS. And when we take the cosine of theta, we are taking the adjacent side and dividing it by the hypotenuse. So that cosine theta is equal to adjacent over hypotenuse. The last one we have is we may not know the hypotenuse. For example, we may not know the gravitational force on this object, but we may know the x and the y components. So then we have what's called tangent. And that is represented tan theta, and that is opposite over adjacent. Or tan theta equals O over A. So these three trig functions are super important to us in order to be able to figure out what's going on with our squirrel, in order to be able to figure out things like what's the normal force, how much is the weight going to contribute to it trying to slide down, how big is the friction compared to knowing its weight, things like that. So let's take another look at this and put some numbers to what we know. Going back to the squirrel, we have our force of gravity, we have our Fgx, we have our Fgy, we have 25 degrees, which is our theta. Let's assume for a moment that the weight of the squirrel is 20 newtons. Okay? And this 20 newtons, it's a little guy, he's just a baby, is what Fg is. So what if I ask you, if the squirrel has a weight of 20 newtons, how much frictional force has to be applied between the squirrel and the roof in order for him to not slide? Well, keep in mind that because he's not sliding, we know that the force of gravity in the x direction must be equal to the force of friction because he's not moving. So because that's true, we can find the force of friction if we find the force of gravity in the x direction. Well, based on the trig functions we just talked about, and 25 being our theta, f of g is our opposite, f of gx, sorry, is our opposite, f of g is our hypotenuse. So sine of theta is opposite over hypotenuse. So the sine of 25 is equal to Fgx over f of g, which is 20. So I can rearrange this and say that 20 times the sine of 25 is equal to Fgx. To find the sine of 25, I'm going to plug that into my calculator, and it's going to give me the value of it. And from the value, we can then multiply it by 20. So 0.4226 is the sine of 25. And we multiply that by 20. And we get 8.452. And 8.452 is Fg of x. Fg of x, remember, is the gravitational force in the x direction of our squirrel sitting on the roof. Because it is a force, and because our gravitational force to begin with was in newtons, this is also in newtons. So if Fg of x is 8.452 newtons, then the force of friction, which is equal to that, is also 8.452. Now, what do we do in terms of rounding here? Well, I really wouldn't keep the 2, to be honest, because the 2 goes to the thousandths place, and we're only giving gravity to the ones place. So I would actually say that I would round this one more time and say that the force of friction is 8.5 newtons. So there's 8.5 newtons of force holding the squirrel up on the rooftop. This is how you use trigonometry for sine. If I wanted to know, well, what's the normal force? What if my second part of my question was to find the normal force? I would do something similar, but rather than using sine, I would use cosine. Cosine of theta is adjacent over hypotenuse. So cosine of 25 is the adjacent, which is FGY, over the hypotenuse, which we said was 20. So again, 20 times the cosine of 25 is equal to FGY. And FGY is going to be equal to the normal force. Why? Because again, it's not moving. The squirrel is not moving. So if I go back to my calculator again and look at cosine of 25, I get 0.9063. So 20 times 0.9063. And notice that I keep a lot more digits while I'm calculating than I do at the end. And that's always a good idea because otherwise you end up rounding way too much. Okay, so 0.9063 times 20. 18.126. Is equal to the force of gravity in the y direction. Again, I'm going to round this sum and I'm going to say, well, this is also the normal force. So the normal force is about 18.1 newtons. So I have my normal force, I have my force of friction, I have used sine, I have used cosine. Tangent would be something similar if we didn't know the gravitational force, but we knew either the frictional force or the normal force. We could use that. Hopefully this gives you a little bit of a brief introduction to trig. Tomorrow in class, we will talk more detail about this. We will do more examples. But I just wanted to give you a brief intro to this. If you aren't sure about trigonometry, if you've never had it before, check out Khan Academy on basic trig functions. You need to be able to use sine, cosine, tangent, and sometimes you're going to have to find out, you're going to have to know how to find the angle. And I will talk about that in detail tomorrow in class. But if you're curious and don't want to wait that long, then go ahead and check it out on Khan Academy. Otherwise, this is the basics of trig, and I will see you later. Bye.